Residual risk is not just a footnote in a manual. Machine documentation contains sentences that look innocent. Do not reach into the machine's working area. Exercise extreme caution. Perform tasks in accordance with health and safety regulations. The user should secure access. Such sentences are not a mistake in themselves. The problem starts when they become the only response to a real hazard. Because a warning in a manual does not reduce risk in the same way as a good design, a guard, an interlock, a guard lock, a safe operating mode, or properly designed service access. A warning informs, but it doesn't stop movement, change machine geometry, limit energy, prevent entry into a danger zone, or make a heavy component suddenly safe to dismantle. And this is exactly where a concept appears that is very often abused in practice. Residual risk. Residual risk is not risk that was simply left with the machine. It is not what was left unresolved due to lack of time, budget, or decisions. It is not an elegant name for a missing guard. It is not a way to shift responsibility onto the user. Residual risk is the risk that remains after the risk reduction process has been carried out. That word after is the most important here. After analyzing machine limits, after identifying hazards, after assessing hazardous situations, after design decisions, after applying technical protective measures, after checking whether the measures applied do not create new hazards. Only then can you honestly say, this part of the risk cannot be further reasonably reduced on the design or technical side. After assessing hazardous situations, after design decisions, after applying technical protective measures, after checking whether the measures applied do not create new hazards, only then can you honestly say, this part of the risk cannot be further reasonably reduced on the design or technical side. This risk remains and must be clearly communicated to the user. Residual risk understood this way is the end of the process, not its beginning. In machine safety, the sequence is of huge importance. First, inherently safe design, then technical protective measures and complementary protective measures. Only at the end, information for the user. If we start with the manual, it is very easy to confuse informing about risk with reducing it, and those are two different things. A manual can be important. It can even be very important. But a manual is not a prosthetic for design. Training is not a guard. A procedure is not an interlock. A warning sticker is not a safety function. And the sentence, "do not reach in," does not settle the matter if you don't first see a design decision that actually tried to limit the possibility of reaching in. Let's take a simple example. A machine has a moving element. In certain situations, an operator may have access to a zone where there is a risk of entrapment, crushing, or impact. It could be clearing a jam. It could be cleaning. It could be adjustment. It could be part inspection. In a poor risk assessment, the topic ends with the entry, "Do not reach into the machine's working area." In a professional risk assessment, this entry only appears after prior analysis. First, you need to check whether the task actually has to take place in the danger zone. Sometimes an adjustment point can be moved outside the area of movement. Sometimes the geometry of elements can be changed to remove a pinch point. Sometimes energy, speed, or stroke can be limited. Sometimes a fixed guard is needed. Sometimes an interlocking movable guard. Sometimes guard locking. Sometimes a special adjustment mode with reduced speed movement. Sometimes hold to run control, or an enabling device. Only when these solutions have been considered, applied, or consciously rejected with technical justification can we talk about risk that actually remains. Without this, a warning is just an entry in a document, and a machine does not react to entries in a document. A machine performs movement, and the person at this machine does not work in laboratory conditions. They work on a production shift, under time pressure, during a line stoppage, during changeover, cleaning a breakdown, or clearing a jam. Therefore, a risk assessment cannot only describe ideal use in accordance with the manual, it must also take into account reasonably foreseeable misuse. not to justify bypassing safeguards, but so that the designer doesn't pretend that the person at the machine will always behave perfectly. If machine safety depends mainly on the operator never making a mistake, never rushing, and never taking the shortest path, then the operator is not the problem. The safety concept is the problem. The second example is less spectacular, but very often comes up during machine acceptance. Service access. A machine has a filter that needs to be replaced weekly, a sensor that needs to be cleaned at every format change, a drive that periodically requires inspection, a component that must be dismantled during maintenance. The manual contains the sentence, "Use appropriate means of access." Sounds reasonable, but technically it is too general if the manufacturer already knows at the design stage where this task will be performed, how often it will be performed, and what load it will involve. Service access is not an add-on to a machine, it is part of its safe use. If a task is planned, repetitive, and necessary to keep the machine running, you cannot leave the user with empty information. Figure out access somehow. You need to define the real working conditions. Who performs the task? The operator or maintenance? One person or two? Are tools needed? Does something need to be unscrewed, slid out, lifted, or rotated? Is there a place to put the component after dismantling? Is there room for a safe body position? Is there room to maneuver? Has transport of parts been planned? Is access safe, not only in theory, but during actual work? The mere existence of a platform does not end the analysis. A platform may look correct on a drawing, it may have a grating, handrail, and stairs. But the key question is, what work was this platform designed for? If someone goes up there once every few months to take a simple reading, that is one situation. If you need to replace a gear motor, gearbox, roller, head, or motor from that same platform, that is a completely different situation. Then the platform stops being just a means of access. It becomes a service workstation, and a service workstation must fit the task. If the manual provides for dismantling a heavy assembly from the platform level, the design must take into account more than just a person with a wrench. It must take into account tools, the dismantled component, the possibility of suspension, the removal path, a transport gate, load capacity, forces generated during dismantling, a place to put parts, and bringing it safely down to floor level. If this is missing, we are not talking about residual risk. We are talking about an unfinished machine operation concept. This distinction is very important. The user, of course, has their duties. They must organize work, train people, supervise procedures, maintain protective measures in working order, use LOTO, and ensure proper qualifications of personnel. But the user should not discover after machine acceptance that they have to figure out a safe way to perform a task that was obvious already at the design stage. If a filter needs to be replaced weekly, access to the filter is not a surprise. If a sensor needs to be cleaned at every format change, access to the sensor is not a problem that appeared on the user's side only after delivery. If a heavy assembly is to be periodically dismantled, its dismantling path is part of the machine concept, not a footnote in the manual.
The third area looks more modern, but works according to the same logic: machine cybersecurity.
Today, a machine is not just a frame, drive, guard, and sensor. It is also a controller, HMI panel, industrial computer, recipes, parameters, user accounts, remote access, updates, configuration copies, and connection to the plant network. For years, it was easy to say, that's a topic for the IT department. But if a breach of this layer can affect machine behavior, it is no longer solely an IT topic. It is also a machine safety topic. If remote access allows changing motion parameters, operating modes, HMI configuration, control logic, or data critical to safety functions, it is not enough to write, the user should secure the network. This is just as too general as use an appropriate platform, and just as weak as do not reach in. Let's imagine a machine that arrives with an active service account, default password, undescribed remote tunnel, and the ability to change motion parameters from the panel level or remote connection. If such a configuration can affect machine behavior, it is not an IT detail. It is an element of the safety concept. Of course, the machine manufacturer is not responsible for the entire network infrastructure of the plant. That would be unrealistic, but the manufacturer is responsible for the configuration in which they deliver the machine and what information they pass to the user. Good information does not say secure access. Good information says specifically what accounts exist, what permissions they have, which passwords should be changed at first startup, how remote service works, who can update software, which parameters are important for safety, how to make a configuration copy, and how to restore settings. Only then does the user know what they are actually taking over. Without this, we don't have a transfer of residual risk, but a transfer of an undescribed problem. And here we get to the point. Residual risk very often lies on the boundary of responsibility between manufacturer and user, but the boundary cannot be blurred. Shared responsibility does not mean that the manufacturer writes a warning and the user is responsible for all the rest. Shared responsibility means that the manufacturer shows what they did on the machine side, what protective measures they applied, what could not be further reduced, and what conditions of safe use they pass on. The user, in turn, must implement, maintain, and supervise these conditions. This is a fair division, not general, not default, not based on a single sentence in the manual. A fair division of responsibility must be specific. Who is to do something, when, during which task, in which phase of the machine's life, by what means, under what conditions, and why exactly this part of the risk remains on the user's side. A good risk assessment leaves a trail of reasoning, not just the result. It shows the hazard, the hazardous situation, the person exposed, the phase of the machine's life, the risk before reduction, the measures considered, the measures applied, what was left after reduction, and the information that goes to the user. If there is only a slogan in the documentation, that is not a trail of a technical decision. It is a shortcut, and a shortcut may look good in a table, but works very poorly on the shop floor. Because a machine does not end with a declaration of conformity. The machine lives on in changeovers, in cleaning, in maintenance, in troubleshooting, in remote service, in updates, and in the daily decisions of people who want to keep production running. If the design does not anticipate these situations, the manual will not fix them. It can describe them, it can warn against them, it can define requirements, but it will not replace a missing design decision. Therefore, with every entry, residual risk information in manual, it is worth asking one question. What happened before this entry? Did the manufacturer actually reduce the risk, or did they just describe it? Did the user get specific information or a problem to solve on their own? Are we talking about residual risk or the consequence of an unfinished design? Because a professional name does not reduce risk. Risk is reduced by a design decision. Risk is reduced by a technical measure. Risk is reduced by residual risk or the consequence of an unfinished design, because a professional name does not reduce risk. Risk is reduced by a desinfecting phasar. Risk is reduced by well-designed access, a safe configuration, and a clear boundary of responsibility. Only at the end does information for the user appear. Then, a warning makes sense.